Good evening, everyone. My name is Sam Nasser, and this is the Cleveland C# user group. A little bit about the group. We meet every month, typically every fourth week. The meetings are free of charge and open to the public, and we cover any and all topics related to .NET. You can find all the meeting information posted at meetup.com at the link listed at the bottom of the slide. As always, a big thank you to our sponsors, the .NET Foundation for sponsoring the Meetup website, and NIS Technologies for sponsoring the virtual meeting space as well as the recording. Some general information if you're joining us for the first time. The user group serves as a platform for people to showcase their skills and share knowledge, as well as networking. Please keep in mind participation is encouraged, and the only stupid question is the one not being asked. So always feel free to jump in with a question or a comment. However, when not speaking, kindly ask you to mute your microphone just to avoid any background noise. And we want to keep it casual but organized, meaning feel free to ask any questions. However, we want to give our speaker enough time to go through the presentation, the slides, and the demos. Lastly, the meeting is being recorded and will be posted on YouTube in just a few short days. So for tonight's feature presentation, we have Cameron Presley joining us from North Carolina, where it's a little bit on the cold side tonight, and he'll be discussing how we can create our own LINQ. And so with that, let me turn it over to Cameron. Cameron, thanks for joining us tonight.
Yeah, Sam, thanks for the intro, man. I definitely appreciate it. So let me go ahead and share the screen. Yeah, don't need that. And if everything's working, you all should be able to see the slide deck. So we'll go ahead and get into it this evening. So good evening, everyone. If you're in the right place, you are here for two reasons. A, you're looking for something fun to do on Wednesday evening. Also, you've been a little bit curious about functional programming, and maybe you've used quite a bit of LINQ in your day job, and you're curious about how does this actually work? Well, in this presentation, not only are you going to learn how LINQ works, we're actually going to write our own from scratch by actually refactoring code that exists today, and then we'll end up comparing it. But let's go ahead and get a little bit more. So my name is Cameron Presley. I am based out of Charlotte, North Carolina, and it is a delightful 17 degrees outside this evening. So a little bit chilly, but not as bad as what you all have up there. I am a Microsoft MVP. All that means is that I love talking to people about technology. I'm not affiliated with Microsoft. I'm not an employee, but I love speaking at user groups. I love speaking with fellow engineers who care about their craft and are wanting to do better. I also am a hobbyist woodworker. All that means is I spend a lot of money to make a lot of sawdust and build projects that are somewhat useful. I like working in the open, working in the public. So this is like a picture of my first workbench, and it's really cruddy, but you know what? I still use it today, and it's awesome. Last but not least, I am a consultant for a company called LINQ Techniques based out of Des Moines, Iowa. What we really do is we help companies make their IT awesome. Are you struggling with getting work done? We can help you with that. Are you all getting stuff done, but you think you should be a lot more effective? We can also help with that. If you're interested in knowing more, or if you just want a second opinion about how things are going, come hit me up after this talk, and I'd love to chat with you more about that. So last bit of note-taking here is, look, Mom, no need to take notes. Everything you're going to see tonight is already live. So if you trust me, you can scan the QR code here. If you don't trust me, that would be my InfoSec people on the call. Feel free to go to blog.softwarementor.com presentations, and you'll see the slide deck, articles referenced, code samples, everything. So I'll do a brief pause here. All right, let's get started. So in tonight's presentation, we're really going to cover three topics. The first thing is we've really got to explore what is LINQ, right? If you don't know what LINQ is, then it's going to be really hard to build our own version. We're then going to speak about the fundamentals, right? So what actually makes LINQ work? And there's three key components that once we understand those components, we can actually build it out. And then once we understand those fundamentals, we're actually going to build out the three most common operators. So that's going to be your select, that's going to be your where, and then we're going to talk a little bit about aggregate, the one that a lot of people don't use, but is actually the most powerful of all the LINQ methods. So let's get started. Let's pretend that we're working in some C# code and you come across this type, a delivery team, right? Seems like a pretty basic record. It's got a name, It's got who leads it, and then it's got a number of people on the team, right? Not too bad so far. So here is some example teams newed up in a list. We've got Alpha Team led by Alice. We've got Back to the Code led by Bob. We've got Skill Overflow Exception led by Cameron. And then we've got Getting Things Done led by Dana. So we've got some example data here. Let's start trying to answer some questions. Let's say that we have a requirement where we got to find all the teams where they have more than 7 people on them, right? So without using LINQ or anything else, you might write code that looks a lot like the following, right? We've got some static function called find too large of team names, takes in that list. We new up a list, we iterate through the teams, we check the member count, we add it, and we return it. There's a lot of boilerplate code here. So I'm going to ask the audience, what are the parts of the code that we actually care about? Where are the business rules that we're trying to solve actually written out at? Anybody want to take a guess? Feel free to come off the mic. Feel free to put in the chat. I would say also send it to me telepathically, but that's not going to help me out a ton because I'm not telepathic. But if that makes you feel better, you can try that too. There's only 2 parts that we care about, right? That if check, the team.member count, and then team.name. The rest of this code is boilerplate, right? And someone put in the chat the if condition. Yeah, that's right. That's it. The rest of this code is fluff. It's stuff I've got to read. It's stuff I got to parse. I have to read a lot of code for day jobs, right? I don't want to have to read more than I need to. So if we were to approach this in LINQ, here's how we would have written this. We would have said, all right, cool, teams.where, give me all the teams where the member count's greater than 7. And then for each of those teams, just give me their name. Here's those same business rules, right? Same thing that we had on the previous slide. But this is significantly less code, right? I'm not having to parse through for loops and if statements and all of that. Just these 2 lines. It's a lot cleaner to read. And to me, that's the power of LINQ, right? It really can simplify a lot of the code we have to do when looking or searching for data. And what I really enjoy about LINQ is kind of this idea of how it works, right? So at a very high level, LINQ is just a set of operations that work on data independent of the source. And I really want to expound upon that. LINQ does not care where the data comes from. It could be from in memory, like you just saw. It could be coming from a database. Maybe it's coming from a network call. Maybe it's coming from your file system. It literally does not care. And you'll see later on that as long as our data implements a very particular interface, LINQ just works. And I find it to be really powerful. And the second thing I love about LINQ is that these operations are type safe, which means if we were to mess something up, we catch it at compile time, not runtime. I don't know about you, but when I was learning how to write SQL, right, I would use like the ADO connection type stuff, or I'd freehand my SQL, and you would write it, but you didn't know if you actually had it working correctly or not until you actually ran the app, right? And then that's when it would break because you forgot to close a parenthesis or you mistyped a column name, right? With LINQ, that can't happen because your code would have never compiled. And if we're going to take the time to work in a statically typed language, I want the compiler to be helpful and help me catch these things sooner, not later. The next thing I want to talk about is why LINQ, and I kind of alluded to this. It's just less code to read. Less code to read, and it's also less things that we can do, which sounds odd, but I'm going to expound upon that a little bit. When designing code, there's this idea known as the principle of least power. And this really smart developer, Tim Berners-Lee, kind of defines the principle of least power as such. When choosing a language, the low power end of the scale is typically simpler to design, to implement, and to use. But the high power end has all the attraction of being an open-ended hook into which anything can be placed. So if you choose a low power language, it's easier to work with, but you can only do certain things. If you choose a high power language, it can do everything, which means it can do everything. So let's compare back to this code, right? So here's our for each loop and here's our if statement. What type of things can you do in a for each statement? Right? Like if I've got a for each loop running, what can I put in between those curly braces? I can put anything, right? I could put throwing exceptions. I could put recursive function calls. I could do all sorts of nonsense that I shouldn't be doing, right? But if I compare that to LINQ, there's not too many things I can do inside where and select, right? And you'll see later on that the type signature for where is essentially some function that returns back a Boolean. That's it. I can't do a whole heck of a lot with that. Same thing for select. Select says that if you give me, in this case, a delivery team, I'll give you back some value. There's not too many ways I can break that and it not be abundantly obvious I'm trying to break it, right? I can slip in some pretty nasty code inside a for each loop and it may not get caught. In LINQ, it's going to stand out like a sore thumb, right? So that's LINQ. That's kind of why I think it's really powerful, but how does it work? Let's dive a little bit into that. So in order to LINQ work, there's three components: funcs, generics, and extension methods. When you combine these three concepts together, you get LINQ. So much so, in fact, that if you were to actually look at the timeline of when funcs, generics, and extension methods were released, LINQ came very soon after. And it had to, because it needs all three of these things to work. So if we're going to build our own version of LINQ, we got to understand these three concepts. So let's dive into it. So funcs I find to be an interesting type because unlike the other primitive types like numbers and strings and booleans or like objects, functions actually represent a type that's a computation. Like you have to invoke it in order to make it do whatever that you wanted it to do. It's not like integers that are just that just happen to be in that sense. And because of that, funcs have an interesting type signature to read. So let's spend a little bit of time, make sure we're comfortable with that. So for example, if you ever see func bracket int get number, this is a function that says, hey, I take in no inputs, but I'm going to give you back a number. And an implementation of such a thing would look like the following, right? So anytime I use, I invoke get number, I'm going to get back the number 2. Pretty straightforward. Let's say though we want to write a function that says, hey, if you give me an integer, I'm going to return back a Boolean. Well, its signature would look like the following: func int comma bool. So the way to read funcs is that whatever the last type is in the angle brackets, that is its return. And then everything before it is its inputs. So an implementation of such a function may be something called isEven, where it says, hey, if you give me some integer x, I'm going to mod it by 2 and check that 0. And funcs can take in quite a few inputs. So for example, we can have a function that takes in 2 inputs, in this case an integer or a string, and in this case returns a string. And such an implementation may be something called repeat, where if you give me maybe the number 4 and the string hello, I will repeat it that many times. Now, this is a whole bunch of gobbledygook code. I don't care if you understand the join in, the range, and the select. I don't care about that. The point is, though, is that we can read the types of a func and understand, okay, this is what the inputs are, this is what the output has to be. The trick is, and you may not have realized it, is that if you've used LINQ at all, you've actually already been using funcs. You may not have just realized it. So here's our code from before, right, where we're using that where and select. If we take a look at that, those 2 lines of LINQ, and then dig a little bit deeper, that where clause, team such that team.member count greater than 7, that's a func. Specifically, it's a func that says, if you give me a delivery team, I'm going to give you back a Boolean. Right? And if we take a look at select, it's also taking in a func, right? It's actually a func that says, if you give me a delivery team, I'm going to give you back a string. And the type system is making this all kind of play well together. And you'll see that a little bit later on in this presentation. And these things are so much like funcs that we're going to refactor this code a little bit, right? So all I did in this code is I lifted what was in the where and select blocks and actually gave them more formal names, like is team too large and get name. Exact same code before, I just made them into their actual funct name types. The other cool thing about Funcs and the .NET compiler is that it does a little bit of syntactical sugar where it can coerce methods and turn them into funcs as well. So, for example, let's say that we wanted to write unit tests on is team too large and get name. It's kind of hard to do that as a func, but if we were to move them into their own functions that then could be called, we could do it. And if you take a look, it's the exact same code as before, right? We're still saying team member count greater than 7. We're still saying team.name. But all we did, we're just now passing in methods. And that's because the C# compiler is helping us out with that. Pretty cool, right? So before we go into the next part of generics, I'm going to take a pause here. How's the group feeling about Func so far? Makes sense? Clear as crystal clear? Maybe the wires are a bit muddied.
So far, so good.
Yeah.
I don't see any comments in chat.
Yeah. I see someone says clear, so that's awesome. All right. So let's talk about generics then, where I find them to be my cup of tea. I've got dad jokes, so hope you appreciate it. Cool thing is, if you've worked in .NET for more than 30 minutes, you've absolutely ran into generics. You may not have realized it. If you've ever worked with a type that had those angle brackets, that's a generic. The most common one you've ran into are lists, right? Like list is a generic type because you can have a list of integers, a list of strings, a list of delivery team, right? And the func type that we just saw is also generic, right? Because it's in angle brackets, delivery team, and bool in this case. What's really surprising to me is that when .NET shipped, it actually didn't have generics at all. Wasn't even in the language. So if you wanted to, so that's why it had like number array and string array and stuff like that, which I find fascinating because I use generics all the time. But let's dive a little bit deeper into generics and when to use them. So let's say that you're writing some code and you're needing a data structure called a queue. Now, a queue has some interesting properties. It has an add where you can put something to the back of the queue, and then you have a pop method that lets you get the first thing in the queue. So you write your class number queue, and you've got and we're using a list to model it, so it's got its own ints or its own list. It's got some elements. We're adding, we're popping, all that fun such. And this works. But requirements change, and you find yourself that actually you need one that can handle strings. So you being a good developer, you write one. But if we take a look at this code, man, this code looks really similar to each other, doesn't it? Especially when you look at the insides of all the methods, right? In both cases, we have an elements list that we're storing stuff into. We're calling add. The pop implementations look almost exactly the same. The only thing that's different in these implementations are the types. And this is kind of your clue that you may be writing something that's generic. If you find yourself writing stuff over and over again and the implementation is exactly the same, just the types are different, you've got generics. So what we can do is we can write a new class called Q, and we're going to do that angle bracket T. Now, once we do that angle bracket T, you can think of T as a placeholder value. And then everywhere that we had either string or integer before, we're going to place it with T. Right, just going to replace it all the way through. And once we do that, instead of saying new number queue or integer queue and string queue, we can just new up the queue type and then pass in some type to be a stand-in for T. So in the first case, it's integer, second case, it's strings. But what's cool is that this will work on any type, even custom types. So if we want to have a queue of delivery teams, we can absolutely do that without having to write the queue object or the queue class over again. That's pretty powerful. And it type checks, right? Because since we specify T at the class level, that means T has to be the same all the way through. So there's no possibility of accidentally mixing up types or doing anything busted there, which is kind of nice. So that's generics. Last but not least, we got to talk about extension methods. So I can give you the technical definition of what an extension method is, but that's really boring. Let's look at through some examples. Let's say that we're working in our code base And we get a requirement that when we are generating a report, we want the date to be in a very specific format, right? Right now we're using like a localized format, and they're like, nope, we always want it, 4-digit year, 2-digit month, 2-digit day, no matter what. We go, all right, cool. So we write some code, right? So here's how we can do that. We say var now equals now, and then for a formatted date, we're going to do a .toString and use that formatted string. And that works. That's great. Solves the problem. Everybody's happy. The problem, though, is that now we've got some inconsistency, because now we have dates in this good format in some places, but we have the old format in others. What can we do to make this be a little bit more consistent? Because I think we can agree we don't want to just copy and paste this implementation everywhere, right? Because then if we have to change it, we have to change it everywhere. That's not cool. So what could we do? Well, one approach to solve this consistent formatting for a date is we could just write a method for it, right? So we can create a static class called dateFormatter, and we can give it a static method called formatDateForDisplay. You give it a date, and it always returns it back in this particular format. And this will work. The fun part, though, is that now in your code, you're going to have to do dateFormatter.formatDateForDisplay all over the place. And that can be a little bit annoying. Right? Just like so. However, another approach we could do is we can leverage an extension method. And what this allows us to do is to add functionality to the datetime object, even though we don't own it, right? That's not our type. That's built into .NET, but we can add things to it. So let me show you what that's going to look like. So we're going to take the exact static definition we had before, and the only change we have to do is we're going to add this keyword in front of the datetime input. That's the only change we got to make. Once we do this, so we have a static method on a static class, we can now, anywhere in the code base that we have a datetime, we now have a method we can lean into. We can just say .formatDateForDisplay. That's pretty handy because instead of having to import this object and do all this other stuff, we can just use that extension method, and that's pretty cool. And the powerful thing about extension methods is that this is the last bit. And extension methods are kind of the secret to how LINQ works. So much so, in fact, that if you were to look up the docs on extension methods from Microsoft, you'll see this quote: the most common extension methods are the LINQ query operators that query functionality to the existing IEnumerable and IEnumerable of T types. Take a note of that last part, enumerable of T, that's a generic. And so this is kind of the power. If you, no matter what structure you write, whether it's a queue, trees, graphs, whatever, does not matter. As long as it has or follows the IEnumerable interface, LINQ just works. And to me, that's just so incredibly powerful that if you create your own type, as long as it implements the interface, you get all this power for free. Amazing. But enough of me talking about funcs, generics, and extension methods. Let's write some code. Let's get into this a little bit more, shall we? So we're going to write our own version, and we've got some guidelines. The first rule we're going to have to follow is that we've got to extend the IEnumerable type. We have to extend off that type because that's what LINQ does today. And you'll actually see that once we extend off of it, it makes our lives a little bit easier. It also has to have the same type signatures of LINQ, which means it has to have the same inputs and the same outputs. If it doesn't, then we didn't really follow LINQ. And this third part that a lot of people don't think about is that it's got to follow the same property of LINQ. Now, I don't know about you, but a lot of people don't really think about the cool guarantees you get with certain LINQ operators. And I'm going to show you some of the fun things you get for free just by using select or where or aggregate. So let's take a little bit of a closer look. So the first thing we're going to implement tonight is how do we change from one type to another using map. Now, in LINQ, this method's called select, but if you look at any other language that has something like this, it's called map. So if you're in JavaScript, TypeScript, any functional programming language, so on and so forth, it's pretty much called map. So that's what we're going to call ours. So what map does is that it goes from a collection of one type, so let's say a list of strings, to another type by using some mapping function. So it can go from a list of strings to a list of integers, for example. Now, select and map have some interesting properties. The first one is it maintains the length of the collection, right? If you call map on an empty list, you get back an empty list, right? You don't get a list with more elements. You also don't get null. You call map or select on a list of 5 elements, you're going to get back a resulting list of 5 elements, not 4, not 6. So that's kind of neat. You're also guaranteed that the results are all of the same type. So if you're mapping from a list of strings to a list of integers, you're guaranteed that everything in the resulting list is an integer. Not like, well, some of them are ints, some of them are booleans, some of them are exceptions. Nope, that's not going to happen. And I alluded to this, but the resulting collection can't be null, which is pretty powerful because that means you don't have to write as much error handling code. And I don't know about you, but I like not writing error handling code. So let's see how we can essentially derive map on our own. Here's our delivery team from before, right? We get a requirement that says, hey, if we get a list of delivery teams, we want to know all their names. And we go, all right, that's easy enough. So we start writing some code. And we end up with something like this, right? We set up an array, or sorry, a list of strings called names, and we for each through the teams, adding the name. That works. We get the ticket done. Hip, hip, hooray. But we find ourselves using this logic all over the place. And remember, we don't want to copy and paste the implementation, right? That's bad. So we're going to go ahead and put this in a shared method called getTeamNames. And I'm going to short circuit us a little bit and go ahead and write this as an extension method. So now, no matter where we're at in the code base, if we have a list of delivery teams, I can say teams.getTeamNames, and it'll run this logic. Pretty cool. But now, as is our profession, we get another requirement where we said, all right, cool, I got all the team names, but now we want to see all the team leads. We go, all right, cool. So we write that extension method. Get team leads, iterate through the teams, adding the leads to the array, and returning that. I say array, but it's a list. So far, so good. But we're engineers, which means we're really good at pattern recognition. So we take a look at this code, and we go, these two things look really similar. Can anyone, besides variable names, what's really the difference between these two methods? Anyone want to take a guess? It's what we're adding, right? In the top case, we're adding the name off of team. And in the bottom case, we're adding team lead. Other than that, this code is exactly the same. So if we had some way where we could choose which property to get off delivery team, we could just use that and then get rid of some of this boilerplate code. So when we run into this situation, we actually can use a func. So that's what we're going to do here. And what I've done is we're going to introduce this idea of a func that says, if you give me a delivery team, I'm going to return back a string. And we're going to call this a getter. So now we have this extension method called getStringValues that says, if you give me a list of teams and then some way to get a string off of that delivery team, I'll give you a list of those results. So once we inject the getter, we set up. So let's see how this would actually be worked. So here's what our implementations for getTeamNames looks like now, right? Instead of that for each loop and everything we had before, we just say getStringValues, and then we pass in our func team such that team.name. And now the same thing for getTeamLeads. So all that code in green, that's commented out. We can throw that away. We don't need it. Any PR that we can do to get rid of code, awesome, all for it. We're so proud of ourselves. And what's a reward for doing good work? That's right, more work to do. So given that we've got a collection of delivery teams, now we need to know the number of how many people are on each team, right? Number of members. So we write another extension method called getTeamCount. Give us teams, we iterate, and we add the member count to our resulting list. We write that, and then we were like, this looks really similar. Maybe we can go ahead and write that get int values. So instead of get string values, we have get int values. Here's its implementation. And now, once again, we're engineers, so that means our pattern recognition game is pretty good. We take a look at both these implementations and we go, man, these look really similar. What's the difference between these two, besides variable names? It's subtle. Yeah, I don't know if it's Connie or Caney, but yes, the return type. Yeah, it's just the types. That's the only thing that's different here. So what's something that we learned early on in this presentation, that if you've got multiple implementations that are exactly the same except for the types, what can we use? Yo, Keith's got it, generics. Cool. So let's do that. We're going to create a new extension method called map, and we're going to give it a generic type called tResult. Now, the reason why it's called tResult is that a naming convention in .NET is that if you're working with generics, it's always going to start with the letter T. In some examples, you'll see the letter T. I like just calling it tResult. But yeah, so we're going to plop tResult in the return list, and that's what the mapper's got to do. And here's some cool stuff. Once we do this, here is our get string values and get int values from before. We don't need any of that code. We can throw that away. Here's what get team names, get team leads, and get team counts looks like. We can just use map. Passing in the exact same func we had before, but because we're using generics, we don't have to have that delineation anymore. And everything's type checking out because, like, let's say get team names. Since team.name is a string, we know it has to return back a list of strings. And in the third example, team counts, .NET knows that member count is an integer. Therefore, the list we return back has to be integers. It can't be anything else. Pretty cool. Let's go a little bit further. Is there any reason why the approach we've taken so far would only work with delivery teams? And the answer to that question is no, there's no reason. What we need to do is add an additional generic, tSource. So now how this reads is that if you give me a list of any tSource and you give me some func that knows how to go from a tSource to a tResult, I can convert everything. So that's what we do. This implementation is so close to the way you have to solve it that here's how select works in Microsoft's LINQ implementation. So I literally just lifted this off their GitHub. This is their approach. It looks really similar, doesn't it? And it has to. Because if we're, this is like one of their performance things, that's why the method's called toList, but the logic's exactly the same. And it has to be, it can't be anything different, right? Because of the properties. Has to maintain the order, or sorry, it has to maintain the length. It has to, it can't be null. It has to be able to convert everything cleanly to the next type. There's no other way to write that code. Has to be this. There's only one small problem. Remember I said earlier that we have to attach this to the IEnumerable type. Right now we're attached to list. So let me show you what we'll have to do to fix that. All we need to do is rip out list, put in IEnumerable, and instead of keeping track of a temp list like we did in the previous, we're going to use the yield return keyword. And that's actually how you make an enumerable out of a list of results. But that's it. Yeah, so Craig, that's a great question. So Craig's like, hey, that's the implementation for toList. So it absolutely is. And the reason being is because .NET has some performance tweaks to LINQ to make it faster. So when you're building up select, it actually is doing the mapper part inside, but it doesn't know whether to make that a list or an array or to something else until you actually bring it into until you actually execute it through to list to array, something like that. But so this is the closest thing that would make it look like the same, but it actually is the same implementation. It's just that I'm not doing the performance improvements that Microsoft does. Great call out though. The big thing to remember about map is that this is great when you're going from a collection of one type to another. If that's all you got out of this, that's great. Let's take a look at the next one by looking at keep. Now, in .NET and in LINQ, this is usually called where. So how this works is that you get a subset of some collection based on a predicate. In LINQ, it's called where. In a lot of languages, it's called filter. And I'm going to be honest with you, this is one of the times where I think Microsoft got the better name. I hate the word filter because it's not abundantly clear if you're filtering things in or you're filtering things out. Whereas where, I think, does a much better job of that. And the word keep also does a really good job of that. But if that's my biggest complaint, we're doing pretty good. So if keep gives us a subset, what are some of the other properties you get for it? Well, one of the properties of the result you get back is that the length of it has to be between 0 and the original length. You can't have a collection with negative items in it because that's a problem. And it can't give you a collection that had more items than what was on the original, right? So if you told me, hey, give me all the evens between 0 and 10, it can't give you back 20 elements. Can't do it, won't do it. The other cool thing about keep and where is that it can't give you back items that weren't on the original list. So if I were to try to find out all the evens between 0 and 10, it won't give me back 22, for example, or 108. Another cool property of where and keep is that it maintains order. So if I'm trying to find out all the positives between 0 and 10, it's not going to give me 8, 4, 6, and 2. It's actually going to give me 0 through 10, the evens only, in that order. So that's pretty nice. Let's take a look at how we can write our own version of keep. So here's your delivery team from before. And we've been asked from the business is like, hey, we want to make sure that we don't have teams that are way too big, because as a team lead, it's really hard to manage teams that have more than 7 people on it. So can we figure out how many teams have more than 7 members? And we go, yep, we sure can. So I've short-circuited this a little bit, but we go ahead and write an extension method called getToBigTeams. It takes in an IEnumerable of delivery teams. We for each through that IEnumerable, and if the member count's greater than 7, we yield return that team. So just building up to what we did for select. So far, so good. We get another requirement, which is like, hey, not only do we want to make sure that we don't have any teams that are too big, we also want to make sure that we don't have any team leads who are leading multiple teams. So can you figure out how many teams that Dana's leading? And we go, yeah, sure, no problem. So we write another extension method called getTeams led by Dana. We for each, and we do our if check of like, hey, is the team lead equal to Dana? If so, return back that team. We have these two extension methods, and we look at them and we go, huh, this code looks really similar to each other. Someone asked the audience, what's really the only difference here besides some naming? Bingo, Craig. Yeah, it's just the predicate, right? It's the stuff inside the if check. So what's a trick that we learned from when we were doing map and select to allow us to be able to change what our predicate looks like? Anyone remember? We can use funcs. The difference, though, is that instead of not knowing what the result is going to be, we know what the result type has to be. It has to be a Boolean, right? Because it's being used inside the if check. So we introduce a new input to get teams by That's a predicate that says if you give me a delivery team, I'll return back a Boolean. And then we're going to call that Boolean as part of the if check. And if you pass the predicate, we give you back the team. Well, once we do that, our get too big of teams, instead of doing that for each loop and all that fun stuff, we say, nope, get teams by, give me all the teams where their member count's greater than 7. So all that code in green, throw it away. And then for get teams led by Dana, same thing. We just pretty much move the exact logic we had in our if check up to be a predicate instead. All that code in green, get rid of it. So the next fun part is this works, but is there any reason why this is only limited to delivery team? Because if I ignored the variable naming, there's not really any types inside the implementation, is it? It's just var, right? The only thing that's important is that the item inside teams, whatever type that is, it has to match the input type of the func. But as long as those two things are the same, this would work. Oh, shoot. If that's the case, we can make that input type generic. So let's open that up a little bit. So here's our implementation for keep. Instead of limiting it to delivery team, we've introduced tSource again. So, and then once we do that, the implementation is exactly the same. We didn't have to tweak it at all. So that's pretty cool. And like I did for map, here's our implementation on the left, and then here's our implementation on the right. Once again, the method is called toList, but it's that same performance thing I was alluding to before. But if you were to look this up on GitHub, this is what gets invoked when you do a toList after you've hit a where clause. Now, the fun question is, how many other ways could we have written such that all the properties held, right? Can't get back a null list. You're going to get a list back of between 0 and the number of items on it. It can't give you items that weren't on the original list, and it maintains order. How many ways could we have written an implementation? And it sounds like a trick question, but I promise you it's not. There's 2 ways we could have written this. And it's based on that if statement. Because remember, everything else has to be the same. The only thing that's different is whether we keep it or whether we throw it away. Which, if you recall, that was my biggest problem with filter at the very beginning. Is that, do you filter it in or do you filter it out? But that's the only implementation. Or those are the only 2. So that's kind of cool. All right. The big thing to remember is that if you're using filter or keep or where, you're only using that when you're trying to find items in your list or your collection that fits some type of predicate, some type of condition. Oh, goodness. Last but not least, going from many to one using reduce. So in LINQ, this is known as aggregate, but a good way of thinking about it is imagine if you took this really nice basket of eggs and you reduced it down to this delicious frittata, right? So the signature for aggregate is a bit hairy, so I'm going to give us a concrete example before we dive deeper. Let's say that we wanted to sum up the numbers from 1 to 10. We could write the following code. We set up some initial value of 0, and then we have a func that's called a reducer. And the reducer takes in 2 arguments and returns an argument, or returns a type. So in this case, the reducer is some function that says, if you give me 2 integers, I'm going to return back an integer. And how it's going to reduce it is it's just going to add the items together. And then to call aggregate, you pass in that initial value. So essentially, what should the result be of aggregate if the list was empty? So if we're adding up numbers and we don't have any numbers to add, the value is 0, right? Because there's nothing to add. And then how do we add 0 to some element out of the list? That's what the reducer function does. So that's aggregate and reduce kind of at a high level what it does. Let's dive a little bit deeper. So let's say that we wanted to know how many engineers do we have amongst all the teams. Well, we could write some code that looks like this, right? I've already short-circuited again to the extension method stuff, so I'm not going to talk about that much more. But we would write our traditional like summing loop here, right? We set total equal to 0, we iterate through the teams, and we say total plus equal to member count, and then we return back total. The next requirement may be like, hey, we want to get all the team names formatted in a very particular way. We go, all right. We know that we shouldn't just do string concat because we're in C# and string concat's really slow, so we're going to use a string builder here. So what we're going to do is we're going to create a new string builder, give it the first line of teams in the company, and then for every team in the list that we're given, we're going to add its name to the string builder and then return back the string builder. If we take a look at these two methods, right, the trick that I kind of been leading us down before doesn't quite work, right? These two things look nothing like each other, right? One of them's working on integers and summing up numbers, though it's working with strings and string builders, right? This is not a generic thing anymore, a func trick. This looks completely different. But they actually have a lot in common. They both follow this pattern of, hey, we have some initial value, and then given some element from the list we're working on, what do I need to do with it? How do I combine it with the initial value? If you're looking at code and you can figure that out, what the initial value is, and then how to add to it, you've actually got an aggregate or a reduce running around. So let's see how we can write this. So here's our reduce function. And so it's pretty clear that we've got to put some generics in place, right? And the first generic is, hey, what are we going to be returning, right? Because in some cases it was a number, in other cases it was a string builder. So that's our first generic, right? So that's why we have t result, and that's why the initial value has to be t result. And then our reducer function says, cool, if you give me a t result and a delivery team, I'll give you a new t result. And then once we have that, we essentially plop in the exact logic we had from our other functions right in here, right? Where we set up the initial value, result equals reducer of that resultant team, and then return result. So we've written this, but how in the world do we use it? Well, here's our total number of members. So we're going to set our initial value to 0. Our reducer func is going to be something that says if you give me integer and delivery team, here's how I want to combine them. Just add the member count to whatever my accumulation is. And then once we've defined those two things, we call reduce. For the formatted team names, very similar. Our initial value in this case is that string builder with the teams in the company appended to it already. And then our reducer says, cool, give me a string builder and delivery team. Here's how we add it. In this case, it's string builder.append line and then the name. Because we have the initial value in the reducer, we can use reduce. Now that you've kind of seen that in play and we take a look back at this example code, we get to ask the fun question again, is there any reason why this is limited to delivery team? And we can take a look at this by just looking at the implementation. Do we actually refer to any types inside the implementation? Nope. The only thing that we care about is that whatever we pass in for the second argument of reducer, so in this case team, it has to match up with wherever the list of items we're working on is called. Like as long as those are the same type, we're good. So we can introduce a second generic, in this case called t-source. So if you give us a list of A's, essentially, and then some initial value of a B, we know how to take all the A's and add them to B. Essentially what we're doing here. Code on the left is our implementation. Code on the right is Microsoft's implementation. Now, there's a little bit of difference of generic naming. I called mine t-source and t-result. They call theirs t-source and t-accumulate. I call mine an initial value. They call theirs seed. And then they've got some error handling to make sure that you don't give us a crap source or a bad func. But if you ignore the error handling, it's the same code, right? I just used var. They used more specific types, but it's the same code. And it kind of has to be. Because once again, there's not really any other way you could write this code that follows all the properties that aggregate follows. The only one that you could do is always like essentially never do the loop and always return back whatever the seed value or initial value was. But if you're doing that, then there was no point of the whole method anyway, which is kind of cool. As a reminder, we use reduce to go from a collection of things to a single value. And here comes the fun part. So we've implemented select and map. We've implemented filter and where and keep. But now what we're going to do is we're going to rewrite those methods in terms of reduce only. So all that code we wrote in the earlier part of the presentation, throw it away. We're not going to need it. And you might be thinking, what? No, we can't do that. That's crazy. Actually, we can. I mentioned earlier that aggregate is one of the most powerful methods of LINQ, and that's because you can rewrite everything in LINQ in terms of aggregate. Now, here's your warning. Just because you can do something doesn't mean you should do something. So what I'm about to show you is code that would work. It does everything it needs to, but your coworkers may not like you for writing it. So don't take what I'm about to show you and start shoving it in your code bases. You're not going to make many friends that way. Craig, you and I are on the exact same wavelengths, my friend. So anytime that you're working with aggregate, there's really two problems you got to solve. What's the initial value? Essentially, if the list is empty, what's the answer? And then, assuming that the list isn't empty, how do we take something from that list and combine it with the initial value? If we can figure out those two steps, we've got this problem beat. So let's take a look. So here's our map from before. So we got to figure out what's the initial value, right? In other words, what do we return if we call map on an empty list? For those who are playing at home, another way to think about this question is, what happens when you call select on an empty list? What do you get back? Yeah, Craig, you're right, an empty list, right? Because remember, select and map, they maintain the length. So if you give us a list that's empty, length of 0, not too many ways we can do anything with that. So it's got to be empty. Cool, that's our initial value. I'm going to cheat a little bit, and we're going to use one of the built-in methods for enumerable called empty. But that's our initial value. So once we have the initial value, we can write a new function called map via reduce, has the exact same inputs and type signatures. And we can actually have VS Code or Visual Studio auto-generate this code for us, because if we say the answer is source.reduce, initial value of empty result, and then some reducer function, this is the type signature for reduce, or for the reducer function. Has to be. Can't be anything else. So now the trick is, how do we, if we're going to add something into T result, let's see here, right? If we're going to add something to the result so far, the accumulation, the ACC, we've got to figure out a way to go from T source to T result. So what do we have access to inside map via reduce that allows us to go from T source to T result? We've got access to something. What is it? That selector function, right? Second parameter of map. Or sorry, the first parameter to map, right, is how do we go from an A to a B? So once we have that selector, we can use it. Go, cool, here's our T result. So we converted it. Now we got to figure out some way to add it. And we are going to cheat again, and we're going to use a method that's built into IEnumerables called append. And that's it. We convert the item to a T result, and then we append it to the accumulation and return the result of that. And that'll do. You just rewrote map as an aggregate. Is this the cleanest thing to read? Debatable. Does it work? Yep, sure does. No problems there. Let's take a crack at rewriting keep. So here's our original implementation. Same question. We got to figure out what the initial value is. So what do we do if we call keep on a list that's empty? What do we get back? Very similar to map in this case. It's got to be an empty list, right? Can't keep anything if the list is empty, right? It gone. So that's our initial value. So using the same trick from before, we can go ahead and rewrite this code. We've got keep via reduce has the exact same inputs. We have the exact return statement we need, right? Source.reduce, empty enumerable, and the reducer func. And then here's our reducer func. We don't have it written in yet, but we know that's its type signatures. So we've got a couple of steps. First, we got to check to see if the item meets the criteria. So we got to figure out, hey, should we add it? And if so, we got to add it to the accumulation, to the ACC. Otherwise, we don't add it and we just return. So for that first step, check if the item meets the criteria. We need something that can tell us that given a T source, it returns back a Boolean, because we're going to need an if check. So what do we have access to in the keep function that allows us to check if something fits a criteria, we'll say? The predicate, right? We can call the predicate and see, does T source pass? So we put in an if else block. So if the predicate of the item is good, we're going to do something. And if it's not, we're going to have to do something else. So, and remember, we've got to return back an IEnumerable of T source. So we're going to use the same trick from before with the append. So if the item passes, we're going to go, great. Take the accumulation, append item to it, and return that result back through. And if it doesn't match, cool. Here's your ACC. Not going to do anything with it. Just return back exactly what I've got so far. And that's it. You just rewrote keep as a reduce. Once again, is this the easiest code to follow? Debatable. Does it work? Yep, sure does, which is kind of nice. So with that, we've kind of really covered the presentation I had planned for this evening, right? We've covered a lot of ground. We've talked about why LINQ is really cool and how it can help simplify your code. We talked about how you have to use generics and funcs and extension methods to really make LINQ work. And then we really wrapped up by writing our own version of LINQ by using map, keep, and reduce, known as select, where, and aggregate. And that's a lot. And you may not have kept up with everything, and that's okay. The biggest thing to remember is that LINQ's not magic, right? It's not some library that was written up in an ivory tower and you can never figure it out. Actually, there's some cool stuff in it, right? There's some stuff that may make you scratch your head, but in reality, it's kind of straightforward. It's really just the composition of those funcs, generics, and extension methods in a very particular way. And with that, that is my presentation for this evening. If you've got questions or want to chat more, you can always reach out to me by dropping me a line at cameron@softwarementor.com. And as mentioned earlier, here's the links and QR codes for the slides and resources. Really appreciate you all letting me hang out with you for this evening. And I hope you had a good time and learned something new. Thanks.
Very nice, Cameron. Appreciate it. That was very well done.
Well, thanks, Sam. I appreciate that, sir.
And you gave some of the best advice that I always give, which is just because you can doesn't mean you should. I couldn't agree with you more on that one. Seriously. especially working with junior devs where they learn something new and immediately the next day they go and implement it. And I'm like, we don't need this. Why are we doing it like that? But yeah, I completely agree with you.
Yeah, but
In any
sometimes,
case,
but sometimes you got to go through it, right? To be like, oh, this is kind of cool, and then you look at it like, ah, this is a bad idea.
right. So wanted to ask everyone, do you have any questions or comments? Feel free to either enter into chat or come off of mute. And if not, I had pasted a few links in the chat window, which we'll go through. And if I may, Cameron, I'd like to take back the screen and just have a couple concluding slides. All right, so in the chat window, I pasted a few links. The one regarding the YouTube channel, if you would please subscribe to that so you get upload notifications once the presentation is uploaded. In addition, there's a link to my blog where I post both technical articles as well as events. You can find that at samnasser.blogspot.com. And again, you can also subscribe to that to get upload notifications. And lastly, if you would please take a moment to fill out the feedback eval so we can provide Cameron with some constructive criticism. Also, for those in the job market, I invite you to check out devitjobs.com. So this is an interesting website that allows you to search by geographical location, whether the job type is working remotely or on site, and more specifically, what type of technologies you'd be working with. Also, whether you're looking for contract or full-time work. Again, so the website for that is devitjobs.com. And lastly, if you have any questions that I can answer for you, my contact information, you can find me at snasser@nistechnologies.com. You can also find all my social links at linktree/samnasser. And lastly, if we're not connected on LinkedIn, let's do so. It's where all the cool kids are hanging out and sharing information, articles, and whatnot. So I invite you to connect with me on LinkedIn. And with that, thanks again to Cameron. Thank you for all who attended, and look forward to seeing you all next month. Good night, everyone.